and welcome, dear students. So this is the second bit of question number 1 of exercise 2.2. So in this question we have to do two things. Number 1, find the zeros of the given polynomial, and number 2, we have to verify the relationship between the zeros and the coefficient. Now, first of all, we have to find the zeros, and for finding the zeros, we have to factorize the given polynomial. Now, to factorize, we need to take the a and the c, that is the first term and the last term, the coefficient of the first term and the last term, and we multiply it. So, we get 4. Now, this number that we get, we have to factorize this number again to find the two terms for splitting the middle term. So now we can see that 4 is, we have to find the factors of 4, and we see that the factors of 4 can be different factors of 4. So we will take the right ones. The factors of 4 can be 4 into 1 as well as 2 into 2. Now, but we need the factors which will give us minus 4 when we add or subtract them. So if we take 4 plus 1, we don't get minus 4. If we take minus 4 plus 1, that does not make minus 4. If we take 4 minus 1, that too does not make minus 4. Let's try with 2 and 2. If we do 2 plus 2, we will not get minus 4. If we take 2 minus 2, then also we will not get minus 4. But if we take minus 2 and minus 2, then we can see that we will get minus 4. So this combination of the factors is the required terms for our middle term. So now we are going to split it into these two factors, 4s square minus 2s plus 1. So now the middle term has been broken or split into two terms, that is minus 2s and minus 2s. When we add it, we will get minus 4. So now we have to separate two terms to find out the factors. Now here we can see that we will try to find out what are the common terms in the first and the second term. Now we can see that 4s square can be written as 2 into 2 into s into s, and 2s can be written as 2 into s, and 1 can be written as 1 into 1 or just 1. So now we'll see what is common between the first and the second term. So we see that 2 and s are common between the two terms. We write 2s, then 2s is left, and then the minus sign, and then the entire 2s has gone. So what is left? 1. We don't write the 0. When everything is gone, then 1 is left. Minus, now here again nothing is common. When nothing is common, that means we have 1 as common. So we'll take that 1 as common, and we will write it as 1 into 2s minus 1. Now why here we write minus 1 and not plus 1? Because we've already taken minus outside. Minus is common. So we have to take minus from both the places. So whenever there is a plus sign, there are two minus signs. So one minus sign has been taken out in the common term, so one minus sign is left. So now we rearrange this into factors. So we have 2s minus 1 into 2s minus 1. So these are the factors of the given polynomial. So we have factorized the given polynomial. Now to find the zeros means the value of the variable which will make the entire polynomial's value equal to 0. We will take the factor as equal to 0. Now since there are two different factors, 2s minus 1, so to find the zeros, we will equate each factor to 0. So we will write either 2s minus 1 is equal to 0, or whatever the other factor is. Now here it is also 2s minus 1, so both the factors are same. So 2s minus 1 is equal to 0. Now both factors are same does not mean we have to write one factor. That means we have to still write two factors, two different factors. So when we solve it, 2s minus 1 equal to 0 and 2s is equal to 1, s is equal to 1 by 2. So similarly, the other factor, the other zeros also, we can solve it and we will get s is equal to 1 by 2. So both the zeros are equal and both the zeros are 1 by 2. Now, so the zeros are 1 by 2, 1 by 2. Now here we can find the sum and product using these zeros that we already have. So 1 by 2 plus 1 by 2 is half plus half is equal to 1. Then product 1 by 2 multiplied by 1 by 2. So the product is 1 by 4. So here we got the sum and the product. Now the second part of the question was verification. So for verification of relationship between zeros and coefficients, we will use the expressions or the formulas that are given for sum and product using coefficients. So we know that the coefficients in this case are a, b and c. So a is 4, as you can see here, because the standard form of a quadratic polynomial is ax square plus bx plus c. So in place of a, what we have? 4. So excluding the square variable, we have 4. Then in place of b, we have along with the sign. Always remember to include the sign. So minus 4 and c is 1. So when we have a, b and c, now according to the using the coefficients, the sum is given by minus b upon a, which means minus of minus 4 upon 4, that is equal to plus 4 upon 4, that is equal to 1. Similarly, the product alpha into beta is given by c upon a. So c is equal to 1 and a is equal to 4. So the product comes here as 1 by 4. Now for verification, now we have found the sum and the product from in two different ways. First we found the sum and the product using the zeros, and then we found using the coefficients. So now we can compare both the results and we see that both the results are same or equal. So suppose we mention this as result 1 and we mention this as result 2. So then for verification we can write comparing result 1 and result 2. So comparing result 1 and result 2, we can see that result 1 is equal to result 2. Hence we can say that the relationship between zeros and coefficients is verified.